Welcome to Reinventing Broadcast, where AI meets content. Hosted by Ben Anker. Let's dive in.
Welcome back to Reinventing Broadcast, the podcast where I explore how AI is reshaping content, strategy, and consulting in real time. I'm Ben Anker, and this is episode 7, diving into week 3 of my executive education journey at Berkeley, neural networks and deep learning.
And I'm HAIley, your AI co-host. Ben, this week sounded a bit more technical, but also very hands-on, right?
Definitely. It was a shift from concepts and frameworks into the mechanics of how AI models learn, especially neural networks. We covered everything from training objectives, data structures, overfitting, to explainability. And it all came together through the assignment, which was built around Google's Teachable machine.
I want to hear all about that. But first, let's set the foundation. What's the biggest shift in thinking you had this week?
It was understanding how much nuance goes into training a neural network. It's not just about feeding it data and hitting go. You have to consider the types of errors, how much you want to penalize them, the volume and diversity of your training set, and how you test the model's proficiency.
And that brings us to your assignment. Ben, one of the most hands-on parts of week 3 was your experimentation with Google's Teachable machine. Can you walk us through how that tool works and how you approached it?
Sure, I can. Teachable machine is Google's no-code interface for building classification models. You can train a model using images, audio or pose data, then test it live through your browser, and even export it to TensorFlow or use it in web apps. It's a really accessible way to understand how a neural network works without needing to touch any code.
And did you know what you were going to use it for straight away?
Actually, no. I started by trying out all 3 types of Teachable machine projects just to get a feel for what was possible. First, I played around with the image classification model. I used some placeholder photos, landscapes, logos, different lighting conditions, just to see how it responded. It picked up on patterns pretty quickly, but I realized I didn't have a meaningful application for it yet. Next, I tested the pose model. That's where you use your webcam to train the model on different body positions or movements. It's fascinating from a human-computer interaction standpoint, but again, it wasn't quite aligned with my broadcast or consulting use cases. Then, I shifted to the audio model, and that's where things clicked.
So audio gave you the clearest use case?
Yeah. I realized I've got a whole back catalogue of podcast audio, plus my audiobook recordings, and even some AI-generated speech samples. That's a perfect foundation for a classification experiment. Once I saw how the audio model worked, training samples grouped into classes, live waveform feedback, confidence scores, I knew this could be useful not just for learning, but for real-world application.
And you eventually landed on the podcast use case?
So yes, after trying the default sample clips and seeing how the waveform interface worked, I structured my real test around 3 core classes. Clean solo voice, pulled from my audiobook, consistent studio-grade recordings. Mixed voice podcast audio, episodes where I'm joined by a guest. Synthetic voices. AI speech from previous tools like 11 Labs. Later, I added a background noise class as well, just to train the model to handle non-voice audio.
And what did you learn about how the tool actually works behind the scenes?
While it's abstracted for ease of use, you still get exposure to core ML concepts like epochs, training iterations, and the idea of overlap factors. You can see when your model starts to generalize and when it struggles. And visually, watching the live waveform shift as the model tries to classify input is really satisfying. It gives you an intuitive feel for what's happening in the hidden layers.
And from that experience, you were able to pivot towards something relevant to your world?
Well, that's what I love about tools like this. You go in experimenting, and before long, you're shaping a domain-specific use case. In this case, it's potentially scalable for media asset review, audio tagging, or AI detection in production workflows.
A great example of learn by building.
Exactly. Start with play, end with purpose. That's when I had an idea to apply it to my podcast audio library. I've got around 50 different audio clips saved, plenty of material. So I split the data into 3 classes. Class 1, clean audio of just my voice, taken from audiobook recordings. Class 2, podcast episodes with both myself and a guest, a real production mix. Class 3, AI voices only, synthetic voices like yours, HAIley. All files were in 44.1 kHz, a mix of WAV and MP3, mono and stereo. I tried to keep the format consistent where possible to avoid bias from audio compression or channel differences.
I love that. So essentially, you were training the model to distinguish your clean voice, your voice plus another human, and not your voice at all, i.e., pure AI voices.
Exactly. Once I uploaded the samples and trained the model, I tested it with new audio clips that weren't part of the training set, and the classification actually worked pretty well. The model successfully picked out which was which, even when the background or mixing changed slightly.
That's impressive. What kind of real-world applications do you see for this?
Well, beyond the podcast use case, I think there's real potential in broadcast production workflows. Imagine training a model to scan incoming production files and flag whether they're clean voiceover, panel discussion, or contain synthetic elements. It could save hours for compliance teams, editors, or even automated captioning systems. Maybe one day it could even identify when a synthetic voice is being used inappropriately.
And that shows the power of classification models. One of the key things you explored this week, right?
Yes. This week helped clarify the difference between classification and regression models. Classification assigns labels, like the 3 classes I just mentioned. Regression outputs a value, like predicting a score or price.
And what did you learn about training quality? Things like loss functions and overfitting?
Great point. The course really emphasized the importance of training objectives and penalizing the right mistakes. If your model gets things close enough, but misclassifies a critical item, say in healthcare or finance, the consequences are huge, so you need to design your loss function to reflect what matters most in your business context.
Were there any surprises when it came to how neural networks can overfit?
Yes, especially in media. You might think giving a model perfect samples from your archive is ideal, but if it only learns how those exact files sound, it might fail with anything new. That's overfitting. When the model memorizes instead of generalizes.
So, more diversity in training data equals more robust models.
Exactly. And I really appreciated the visual breakdowns this week. The module walked through convolutional neural networks used in image recognition, recurrent neural networks, great for sequences like audio, and even touched on deep learning and generative models.
I heard you also explored adversarial inputs. What was that about?
It was eye-opening. Adversarial inputs are tiny changes to input data that trick a model into making the wrong decision. For example, a slight pitch shift in a voice clip might cause a model to misclassify it. This ties back to model robustness and how vulnerable AI still is without proper testing.
So, what does this mean for your own work and your evolving capstone idea?
It's definitely helping me think more critically about the training data I'd use in a future solution. If I move forward with a broadcast-focused capstone, I now understand how crucial it is to plan for data variety, model testing, and real-world error scenarios.
And what would you say to someone learning about neural nets for the first time?
I'd say start small. Use tools like Teachable Machine. Think of a fun experiment you can actually test. Don't just learn theory, build something. That's when it clicks. And most importantly, get comfortable with not knowing everything. This space is still evolving.
That's great advice. So, what's next?
Module 4 unlocks soon, and it's a double assignment module. It'll be covering computer vision, recognition systems, and advanced natural language models. I'll be back next week with more reflections as I continue this journey. And as always, you can follow along right here.
Can't wait. Thanks for walking us through another fascinating week.
Thanks, HAIley, and thanks to everyone listening. Stay curious and keep building.
Thanks for listening to Reinventing Broadcast. Subscribe for more on AI content and the future of media. And visit ancast.tv for more info on Ben himself, the resources, other content, and news.